The weights of full boxes of a certain kind of cereal are normally distributed with a standard deviation of decimal 27 ounces. A sample of 18 randomly selected boxes produce a mean weight of 987 ounces. Find a 95% confidence for the true mean weight of a box of this cereal. We use a 5-step model to identify the confidence interval for the true mean weight of box of this cereal. First step in this model is to describe the population parameter of concern. The mean weight of all boxes of this cereal is the parameter of interest for this question. Step 2 is to specify the confidence interval criteria. And we need to check the assumption first. The weights are normally distributed. It's already mentioned in the question that the weights of full boxes of a certain kind of cereal are normally distributed. After we have to identify the probability distribution and formula to be used. We can use the standard normal variable z because we have the standard deviation of the entire population given. This standard deviation is decimal 27 ounces. And we need to determine the level of confidence. The question asks for 95% confidence. Step 3 is to collect and present information. The sample information is given in the statement of our problem. We have a sample of 18 randomly selected boxes, so the sample size is 18, with a mean weight of 987 ounces. So the mean weight for our sample is given. Step 4 is to determine the coefficient interval. We have these kind of cereal boxes are normally distributed, so we can use the normal distribution. We are looking to build a 95% confidence interval. So the error can be 5% due to the perfect symmetry. So we might have 2.5 left in the right side and 2.5 left in the left side. We are looking to calculate this cutoff point. So we can use the normal table to identify this z value, and because the area under the normal curve is 1 and we have a perfect symmetry, half of our area is 1. We have in the right side 2.5 left, so the remainder up to half is 47.5. So the area that we can read from the table is this one, 47.5. So we need to use the normal table to identify z corresponding to this area of decimal 4750. So let's check that normal table. So we identify z corresponding to an area of decimal 4750. So this z is 1.9, and let's check the second decimal of z value, it's 6. So 196, it's z value 196. And now we can calculate the maximum error of estimate. So the error is this z, the coefficient, that confidence coefficient that we just read from the table, times the standard deviation of the entire population divided by square root n, where n is the sample size. If we plug in this formula, we have 196 times the standard deviation was decimal 27 divided by square root 18. So this value, you can see, I put it here, is decimal 1247. We need to identify the lower confidence limit and the upper confidence limit. we can calculate based on this formula. Will be the mean for our sample plus and minus error. So if we subtract the error from the mean weight of our sample, we have the lower limit of this interval. So it will be 987 minus decimal 1247. This gives us a value of 9.75. To calculate the upper confidence limit, we add to the mean weight for our sample, 987, this error, decimal 1247. If we add this one, we have a value of almost 10. So we have the lower and the upper confidence limit. Now, the last step in our model is to state the confidence interval. So 975 ounces to 10 ounces, it's a 95% confidence interval for the true mean weight of cereal boxes.